Okay, just like before where we converted this into percentage weight per volume, let's turn it into a ppm now. So when we look at ppm, okay, we're talking about parts per million. Now, don't worry about the equivalent units. It's actually unimportant and it might confuse you. I prefer that you actually understand where this term comes from and how to calculate from there. Let's start again with, we have our 16 grams in 1 litre. Now, remember that conversion, that 1 mil, okay, is equal to 1 gram. If we kind of consider this, then we can say once again that we have 16 grams, right, per 1,000 grams. Right, what we have now, grams per litre, is essentially, we have this in parts per 1,000 now. Okay, we've got this in parts per 1,000. What we'd like to make this into is parts per million. So let's use that same technique we used before. For 1,000 to get to a million, we need to add 3 zeros to it. So we need to multiply this number by 1,000. So if we do that to the denominator, we also need to do that to our numerator. Okay, so let's turn this into 16, then turns into, okay, well, we add 3 zeros to it. So this turns into 16,000 grams. Okay, that 1,000 grams, we multiply that by 1,000, that turns into 1 million grams. Now we have grams in grams, parts per million. So we have a 16,000 ppm solution. You can do the same thing for a billion. So instead of multiplying by 1,000, we need to add another 3 zeros on the end of that. So you need to multiply that by a million. Now, 16,000 ppm, it's a big number, 16,000. So when we're talking about something that has a relatively high concentration, like 16 grams per litre, parts per million might not be that appropriate. If you have something a lot smaller, it might be more appropriate. So let's go the other way. Let's convert something in, let's just say that we've got something in 3.6 parts per million, and I'd like to convert this into grams per litre. Let's go the other way. So 3.6 parts per million, so we might be describing, I don't know, the carbon monoxide concentration in the air, something very small, which wouldn't be dangerous at this level, I don't believe. But let's do this. So 3.6 parts per million. Okay, so we're saying we've got 3.6 grams of this substance now, okay, in 1 million grams. Okay, we need to make this million grams. Litres, we know, weighs 1,000 grams, so we need to make this into 1,000. So we're going to divide by 1,000 here. So we get rid of these 3 zeros, and then we end up with 1,000 grams here. We're going to need to do the same thing to the other side. So 3.6 divided by 1,000, we're going to take this decimal place back, 1, 2, 3. So we're going to end up with 0.0036 grams, okay? And now this is the equivalent to a litre. So we have 3.6 times 10 to the minus 123, right, grams per litre. All right, and this is equivalent to 3.6 ppm, so that's going the other way. You can do this with all units, you just need to consider what they're parts of. So all percentages are parts per 100, parts per million is obviously parts per million. It's equivalent to milligrams per kilogram, but not a good conversion to remember. You're better off to work through it and do it this way, and then you'll be able to work out any scenario.